In this session, I'll be explaining external computational fluid dynamics and give live demonstration on external incompressible CFD analysis of small UAV, wing, fuselage, propeller and landing gear. Fluid flowing over two cylinders in an open surrounding as shown in figure A is an example for external flow. In external CFD analysis, the fluid is initialized with inlet and outlet boundary conditions at top and bottom boundaries of the domain as shown in figure B. Now I'll give a live demonstration on external incompressible CFD analysis of small UAV using SimScale software. To open SimScale software, go to browser or Microsoft Edge and enter simscale.com. SimScale is a tool to run simulations without need of any powerful computers. As SimScale is a cloud software, you can carry out your simulations using laptops, tablets or Android phones. Next, go to Dashboard, create new project, enter your project title, describe your project and select the category. I'll give the project title as Small UAV. And describe it as external incompressible CFD analysis. Choose category as aerospace and click on create project. This is the interface of SimScale software. To start analysis, first step is to import geometry. To import geometry, click on the plus icon in geometries. Click on import from computer. Select geometry from your computer. Click on import. This is the geometry of small UAV for our analysis. Next, we will use enclosure function to create domain or virtual wind tunnel. For that, right-click on UAV, go to Add Geometry operation. Here is the enclosure function. While creating domain, some points that need to be considered are the domain must be far away from the geometry. Domain dimensions must be considered such that the flow near the geometry is not affected by the boundary conditions. Bigger enclosure or domain is always better. The standard dimensions of the domain for analysis are: the inlet wall distance must be 10 times the length of the geometry. The outlet wall distance must be 15 or 20 times the length of the geometry, and the other sides of the domain must be 10 times the length of the geometry. Now enter the dimensions of the enclosure. Click on Start. The domain is created. Hide the domain, right click, hide section. Next, select active box selection. Select your UAV geometry. Go to topological entity sets. Click on the plus icon. Give a name. And click on create new set. Right click, show all. This completes the pre-processing step. Let's start the second step, that is solver execution step, by creating simulation. To create simulation, click on the plus icon in simulations, select incompressible, click on create simulation. Here turbulence model I'll keep the same K omega SST. K omega SST is a standard industry model which is good at boundary walls and provides better prediction of flow separation. Time dependence I'll keep the same steady state and save it. Next, to apply materials, click on the plus icon and select air, apply. I'll keep the same default values for kinematic viscosity and density. Save it. Initial conditions. I'll keep the same default values. Next, we'll apply boundary conditions. To apply boundary conditions, click on the plus icon in boundary conditions. Select velocity inlet. In velocity inlet, you need to enter your inlet velocity. I'll give it 10 meter per second and select the inlet phase for your geometry. Select translucent surfaces with wireframe. So the air will be flowing along x-axis. So this will be the inlet. Select the inlet phase and save it. Next, apply pressure outlet. Here you need to enter the gauge pressure. Select the outlet phase. So the outlet will be opposite to the inlet. So this is our inlet. So the opposite phase is this. Select the outlet phase and save it. Next, follow the same procedure and apply wall boundary conditions. In velocity, select moving wall. The wall along which the velocity magnitude is specified is defined as moving wall. Here, enter the inlet velocity. It is 10 meter per second and select the moving wall. As the air is flowing along x-axis, so the moving wall will be this. Select and save it. Next, apply same wall boundary conditions and select slip wall. The free surfaces of the domain on which the velocity is 0 is defined as slip wall. The free surfaces of our domain are these. Select the three surfaces and save it. Here we are done with the boundary conditions. Next, in advanced concepts, numerics, I'll keep the same default values, save it. Simulation control, I'll keep the same values, save. Next, we'll be assigning the result control. Click on the plus icon in forces and movements. Add forces and movements. In forces and movements, you need to enter the CG value of your geometry. And select the UAV in topological entity set. You can see the CG of the UAV here. And save it. Click on the plus icon in forces and movements again. Add forces and movement coefficients. Here enter the same CG value. Y, Z are 0, 0. Lift direction is along Y. Enter 1 and remaining will be 0, 0. Drag is along X, that will be 1 and the remaining 0, 0. Pitch axis is along Z. Enter 1 and the remaining 0, 0. The free stream velocity that you had entered at the inlet is 10 meter per second. Enter the same and enter the length of the UAV geometry. And select UAV under topological entity set and save it. Here we are done with setting the result controls. Next step is to generate mesh. To generate mesh, click on mesh. I'll keep the same default values. To generate, click on generate. Mesh is generated on the domain and the geometry. You can see. Right click, hide. You can see the mesh generated on the UAV geometry. Right click, show all. After the mesh is generated, The next step is to run simulation. Before that, ensure that each node in the navigation tree has a green tick to run your simulation. So here we have green tick on each node. So I'll move to run the simulation. To run the simulation, click on the plus icon. The simulation duration will be given here. It is 30 to 50 minutes. And to start, just click on start. To complete the simulation, it will take 33 to 50 minutes now. The simulation is completed. With this, the solver execution step is also completed. The last and the third step in analysis is post-processing step. We'll move to the post-processing step to analyze the results that are generated after simulation. To view the lift, drag, lift coefficient and drag coefficient values, go to force plot. Click on forces and movements. Pressure force X is the drag force and pressure force Y is the lift force. Disable the other options. First we'll see the lift force. Pressure force Y or lift force is 30.808 Newton and the drag force is 3.7246. Next, to view the lift and drag coefficient values, go to force coefficient plots. Click on force and movement coefficients. The lift coefficient is 0.176 and drag coefficient is 0.0245. In this way, you can view the values of lift and drag forces, lift coefficient and drag coefficient. Next, to view the velocity and pressure counter plots, click on Run and click on Post Process Results. Parts color. In parts color, select pressure. Hide the domain. This is the pressure counter plot of the small UAV geometry. Next, for the velocity magnitude plot, add cutting plane. Right click, show all. Select Y, Z orientation. Disable parts color. This is the velocity magnitude counter plot. of the small UAV. Right click on the scale. You can also change the color scheme. And the division numbers, you can increase or decrease. To view the streamlines over the surface of the UAV geometry, add particle trace. Disable cutting plane. Right click, show all. In particles color, select solid color. In particle trace, you can change the horizontal and vertical seeds, space and size of the streamlines. I'll change it to 50. This also 50. Before that, you need to click on the surface of the domain. After clicking it, you can change the values here. I'll change the size. Hide the domain. So these are the streamlines flowing over the surface of the UAV. You can also animate the streamlines. This is the front view of the UAV. You can see the streamlines. As I said, you can also animate the streamlines. For that, click on animation. Select particle trace. You can also increase the steps and animation speed and play. You can see the vertices generated at the wingtips. This completes the analysis of small UAV. With this, I will end up this session here. Thank you.